All right, so thank you very much to all participants, especially to our honorable speaker, Associate Professor Dr. Teh Chee Siong from Faculty of Cognitive Sciences and Human Development. Before I pass to moderator, I would like to giving a brief introduction for this webinar for today. This webinar actually in continuity with the Artificial Intelligence Hub launching, and this webinar organized by Artificial Intelligence Hub with collaboration of Center for Applied Learning and Multimedia. So this is the fourth series, because we already started our workshop in Artificial Intelligence in Teaching and Learning at the early of 2024. All right, so this is a fourth series of Artificial Intelligence webinar series and focusing in teaching and learning. So with that, I hope that the participants will stay tuned with our speakers and webinar series. So before, without further ado, I would like to pass the station to our moderator, Dr. Ng. Over to you, Dr. Ng.
Okay, so yeah, good morning. Thanks, Dr. Mazlina. Okay, good morning to all participants here today, our speakers, okay, all professors, okay, so all lecturers as well. Okay, so before we start our webinar today, let me introduce the speaker. Okay, so Associate Professor Dr. Teh Chee Siong obtained his master degree in computer graphics and virtual environments from the University of Hull, UK, okay, in year 1997, and PhD degree in artificial neural networks from School of Electrical and Electronic Engineering, University of Science, Malaysia, in year 2006. Okay, so his research mainly focuses on the areas of artificial intelligence, soft computing, okay, that data visualization, machine learning, and distributed virtual reality. Okay? So, Associate Professor Dr. Teh and his research team have developed multi-dimensional reduction and data visualization tools for nonlinear data analysis. Okay? Real-world applications of the tools have been demonstrated in the field of medicine, education, product design, computer security, okay, effective design, and water treatment plant. Yeah. So besides artificial neural networks, his research also focuses on fundamental methods used by data scientists, including statistical methods, probability, machine learning, and algorithms, okay, and other effective approaches for data analytics. So in recognition of his contribution, he has received numerous awards such as USM Sanggar Sanjong Award. Yeah, this is for under the journal publication category. Okay, the Best Paper Awards, UNIMAS Publication in High Impact Journal, and UNIMAS Excellent Service Award. Okay, so he involved in many research projects and has actively published his research findings, yeah, in numerous international journals. So he served as the Deputy Dean, Research and Innovation of the faculty, okay, from 2007 to 2009. President of the International Association on Cognitive Science from year 2013 to 2015. Okay, so the chief editor of the Journal of Cognitive Sciences and Human Development. Yeah, so key labs leader of the Big Data and Data Analytic Working Group at SDEC, and he is also member of many journal reviewer committees. So basically, that's his bibliography. Okay, so quite a long one. Okay, so I think without further ado, I'll pass the time to Associate Professor Dr. Teh. Yeah? Okay.
Yeah, thank you, Dr. Ngu, and thank you for our come for this initiative, and also our CDO office of the AI Hub, so that make this event a reality. And of course, I want to project a bit of my background, and especially when I'm with the Faculty of Cognitive Sciences. So then there will be just some background why I'm in this faculty, and I think Dr. Ngu has given you some background of my academic training. And I think this is relevant for me to let you have some view of what I have go through with my career with the UNIMAS. And thanks a lot to UNIMAS that actually giving me this opportunity with my career with this institution for almost 30 years. And then the training provided is excellent, especially that is very related to what we are actually want to mention for today in the area of, let's say, computer graphic, why this is actually related to the AI. So I think later on, we will maybe in our discussion session, we will talk about why the GPU and the hardware of the AI might be also related to what this computer graphics knowledge. And also the thanks also need to be mentioned, especially to my senior late professors Mazuki and with the Cairo in 2007. And what I'm saying here, he is our senior who actually bring this idea to our faculties. What I'm saying here is we have championed in our field long times ago. Malaysian, and actually they have been involved in AI for many years. And also my supervisor who are actually now with the Daikin University of Australia, who bring me to this area. And as I say, why I'm giving you this background is to let you know the area itself is not just happened now, and that has been in academic or maybe in research or in industry. AI has been implemented across the century. So why I'm giving this talk is actually a discussion rather than giving you any specifics knowledge about AI. But I think it's still important for me to let you know some fundamental out of it. And we are actually dealing with some area, the area of AI, not in like what we are using Microsoft Word, or Excel, who might need some skill of operating the system or software, then will be sufficient for you to position you in this advancement of AI. So there will be some technical know-how, or we call it technical literacy of the AI to many of us. So today I just want to share a bit of what my knowledge about this area to all. Of course, it will be quite a long one, but of course, what I try to do here is I will highlight the important component that might give you at least to start with some part in AI that will benefit you for your further adventure if you want to involve in this area in the near future. So actually, I just want to divide my talk into this few sections. Later on, you will see I will go through one by one, and with the times, approximately 1 hour and 30 minutes with the talk like this, I will think you will lost the focus. But never mind, I will also highlight the important component, then we will go back and I will repeat this again, a certain component that will be benefit you in your academic research, or maybe if your venture into the AI area. So these are the terminology and focuses that is should be not really difficult for you, and then you have already looked at this many times in your initiative to learn this in YouTube, or maybe it's any learnings material. So these are the main component that I extracted with this multidisciplinary study in AI. So I will just provide you the important component out of it. To start with, I will just want to highlight one issue. Again, this also always the highlight for many AI research, and I will bring you to this. And of course, I'm not going to play the video here. So this is from Jensen Gabriel, a philosopher and a research scientist at Google DeepMind. I want you to, maybe you can screen capture this slide, and then you might able to play this talk when you are free. Okay, that's why I say when you are free, it will be approximately 1 hour and 30 minutes, and there will be approximately 40 minutes for the Q&A. And again, why this is an interesting topic here is because we also need to know the ethics issue of AI, and also what kind of alignment, the AI value alignment, and you can see the the contribution of this speaker with to share with us with his talk in this. And I just want to coin his word, the winds of change are definitely blowing. This train continue to evolve. It's crucial to understand the AI models and their potential impact. So the keyword, two keyword here is the AI models and also their potential impact. So I will be just highlight one more aspect that he mentioned here is the advanced AI assistant. So what is this actually is, for his definition here is an agentic model that will be able to communicate. They will have some natural language interface like what your ChatGPT is, more or less, that can complete a large suite of tasks on behalf of a user. And it's actually across ranks of domain in line with the user expectation. So this is what we foresee will happen in the near future about the advancement of this. We call this as an advanced AI assistant. Okay, so you will see from my slide over here, if you can notice that this thing is actually familiar with you. So like, for example, Apple series that you already use in your Apple's computers that can speak to you with some narrow AI's capability, and also what you are very familiar with now about the general purpose model. We call that as a general purpose model because it's a big model that can answer most of your questions like ChatGPT and GPT-4 that you are already very familiar with. And we will foresee that the advancement in this, according to him, it can be your creative partner, it can be your research assistant, it can be your educational tutor, or it can be a digital counselor or life planner in near future. So what should we do? You see, however, they also have a significant impact on society and drastically alter how people view about AI. So this is what he is trying to position to us in our in his talk. I'll just go through a bit for what he's trying to highlight. So is the question raised by him, what might a work populated by advanced AI assistant look like? How will people relate to new, more capable form of AI than human-like traits, and will which they are able to converse fluently? So this, I just want to not to mention this, but that this is some point that is actually highlighted. And please, if you have time, and just go through this before we are actually position ourselves, if you want to know more what this AI stuff can do for us. And I also want to highlight our works with Professor Chen about the AI educational companionship, which has been published last year in the International Society of Scholarship and Teaching and Learning. So we have at least give you a short presentation in terms of write up our position of both of us about what this AI can be your educational companionship. And the highlight of what our talk here is actually, we highlight certain learning design process like learning outcome. So we need to focus on higher order thinking, learning resources. We prefer learning content by conversing with their new non-human personal tutors. We have some learning activity that need to be modified, and we have some learning assessment that should give some attention to. So against this website has been also giving you some access to this, and later on you might have to go through, if you're free, about our position about this AI in educational, especially learning design. So I want to project another one here is the business use about AI in 2024. Of course, this survey is actually conducted on the year of 2023 last year, and with the 600 American business. And of course, this is quite a famous survey by Forbes and Com. It's an advisor, mostly actually active in knowing what's the business nowadays, especially focused in America. And I just want to highlight also some finding that the top ways a business owner use AI. So they're based on the survey. These are all the possible field that can be used, or maybe not to replace. It means that it can be used together with human especially with this, you can see with this field of in their business. And I just want you to take some notes, like for example, customer service. I think they might be also will be implemented in our maybe our Maybank for the near future, and then there will be some accounting. So, for example, that is based on human rather than now we need to have the server operation maybe need to be replaced by the automation in AI. So just give you some overview of this, and there will be some key finding for us to note. 50% is actually related to cybersecurity and force management, and there will be nearly 2/3 is actually related to customer service. Nearly half is actually to craft internal communication. And then the ChatGPT also can be foreseen to be used by many of them. 97% of the business owners believe the ChatGPT will help their business. And I try to project here is not to replace, means it is to help. So one of these 3 business plan is actually write website content. You can use ChatGPT to write website content, to write content in other languages also. And of course, there will be a doubtful case, 25% concern about AI affecting website traffic, because most of the AI solution now in business is cloud-based. Cloud computing means that you have to access the services from your office, then there will be affecting your web traffic. And another one here is 40% say that there will be an over-independence over the technology due to AI use. Over-dependence on technology due to AIs. Okay, so what should we so what is actually our position here? So do we have a positive about AI or we have doubtful about it? So I try not to answer this, and then later on, maybe through our discussion later in the Q&A session, maybe we can have a position, maybe later on to talk about it. I just want you to look at this generation chart, and this is very famous generation chart. Then I just want to draw your attention of my time, let's say in 1980s. So we have the Apple computer, we have the compact disc. This is when I first joined Unimaster. We have a computer with CD, then we are very happy. We have the computer with networks, so we are very happy with this. And then this is the case what happened 30 years ago. So, but this is what is after 30 years. So you can see the present from 2010. We have a mobile, we have the social media, boom. We have the integrating AI with the AI's experiences now. So these are all happening. Advance in cloud computing, providing scalable AI solution. So this is what happened for our generation now. So what will be the case for our next generation? For why I'm showing you this chart is say that the thing is never been looking backward. So thing will be actually looking forward. So like the Tesla, auto car, driving car. So for the future generation, especially for our students, so what they need to face for the future and their prospect might be related to what I'm trying to mention here. It's a general AI and advanced automation, enhanced human AI collaboration with AI taking more complex tasks, and also the autonomous rule. And also, of course, we are continuing focusing on the ethical AIs, good AIs, AI for peoples, and this type of policy and guidance, regulation, and also we also take note of societal impacts. So this will be just to mention the change will not be just waiting, but it's just progressing according to times. So give this view to you. So of course, my position is not to support or not to support the use of AI. No, my talk today here is to let you know how we will be able to understand this. At least I hope with my talk today, so you have at least 50% better than the people out there who might have no idea about what AI is. At least you can have that objective achieved with this short presentation. So the subsequent one here is some terminology. So I think this is also very usually people want to present this to many of us. But this is the facts. this is what happened now, and then up to now, at least. So these are the key area that we have to know about the AI. And so the circle show you here is sometimes we have confused how is machine learning AI, is deep learning AI, what is AI? Is AI everything? So AI here and AI there. So no, for an academic, so we are actually quite firm about what this subset is all about. So normally, what you observe now, again, so it will be related to AI. So later on, we will go a bit details. And there will be something that you might be able to use for your research. Like, for example, you want to do data analytics. So you might need to know what this machine learning is all about, the methods of doing it, the methodology of doing it. And then will be have some kind of what called deep learning, this type of stuff. And why this become famous? Because it's so powerful nowadays. And of course, we have our data center. So this data center and our data science related issue will be actually a subset for what you can see from the diagram here. So, but this is basically an overview, but this is still not really the important one. So why not we give you an overview of what current AI look like. But before that, from this presentation, you will see that we still have one thing that is important to know. The AI is not just happening now. We have a good old-fashioned AI. So if you are in the computer science area, so this is the topics of AI that you have to learn. And this is very logical, and they are probabilistics oriented, and they will be fully mathematics and equation that you might have to enjoy when you are doing this. But good news here is with my presentation, I will just zoom in into something which is relevant. Right? Of course, the old folks might be relevant if you are in the computer science. But as a general layman like us, do we need to know all this? Do we need to know all the detail of what computer scientists is actually learning? No, I will just give you some key concept today. So for example, the deep learning people has been mentioned this all the time. And then we have the transformer, so which is actually related to generative AIs. We have the deep multi-modalities transformer. Even you can see now actually we have the model that can see and then can hear, that can visualize, and to a certain extent can speak. So I think you know this and here. See, when we say see, we say the system able to generate the image for you. It's able to hear because you have the device that can assist you for translation. One language to another language, you speak to that device, and the device can translate it into another language. So we have the visualizations, like for example, you can generate more and more information in the visualization form, which is actually you see has a certain of intelligence of doing it. And you can see when we talk about this, see, hear, visualize, speak, it's very near to what human being. You see, we have eye, we have our language, we have ear, then we can see, we can hear, and then we can speak to people. So, but only one thing that is actually missing here is our touch. So that is another input that might have a difficulty for the industry or the researcher that now to incorporate this into a multi-modality of our transformer now. So touch will be another dimension for what I can see for the evolution of this AI system. But one thing that we are actually want to project, especially in our field of cognitive science. So we all know the human cognition not only able to process the information from hear, visual, speak, but we have memory. The transformer got memory. Do we have the large model that can associate with the memory that you input to the model? I'm talking about the memory like human being, that the memory and the reasoning like what human can do. So of course, this is another dimension that the researcher in this AI will look into it in the near future. But this is overall what this AI nowadays is actually formed. Just want to recap you. So we have the old patient AI, which we have learned 20 years ago, and then this also very relevant. Then we have the deep learning and transformer, a deep multi-modality model, and these are all present now that we can use, and we can observe the response of this model. Then you even can evaluate that. And what happened next will be our question. So you can see now we have already at least know what this AI is all about. I think one more subject that I want to focus to you here is the machine learning modules. So for many of us as an academic, or maybe you are in your young career of you, maybe you are just finished your PhD, so you want to do some data analytics. Maybe there was a certain approaches that you want to apply for developing a predictive model. So you want something that you can do more about the data that you have. So I want to introduce to you the field of machine learning to many of you. If you are not familiar with this, of course, today I will not go into the details algorithm. I will just want to highlight some potential topic or potential method that you can implement for your research specifically. Of course, if you want to extend your models into AI, so this also will be the first and the initial stage that you can start with if you want to plan your research in this direction. Of course, if you have more and more data, you want to use this for industry. So for the last 20 to 30 years, so many research has been reported the use of machine learning for data analytics is an effective one. Okay, so you can see what we can see from this slide here is a learning algorithm. It's a machine learning algorithm. So what is actually the field of research that you can involve is let's say pattern classification, pattern clustering, prediction, pattern recognition, regression, and deep learning. So this seems to be a bit technical to you. Why not later on I just share you the topic of research, then you have better understanding. Hey, why this method will be appropriate for us. Okay, if I have a set of data, what can I do about it? So, of course, to focus in this part, this is machine learning. It's not the deep learning, this type of stuff yet. So let me present this machine learning to you first. This is the first part of my presentation, and this is the first highlight. And this highlight show you that is this model that is actually appropriate for data-driven analysis. So the algorithm learn from data. If you have data, so how can we learn from data? What it means by learn from data? So what is actually about this? So later on, we will be able to see it from my proposed research topic later on. Then you have a better understanding. So the main thing here is this discover pattern and relationship within the data. So many statistical tools that you are familiar with might have difficulties to do this if you have a set of data, especially pattern discovery. And then this is quite a challenging task if you are implementing some of the traditional statistical method. Of course, we also know that the machine learning can give us some probabilistic prediction, and we can have some kind of uncertainty in your model, then you will be able to capture this probability behavior. And one more important thing here is the machine learning is able to give you an adaptive feature. It can adapt and improve their performance over time as they encounter more data, making them suitable for dynamic and evolving scenario. So, of course, when I give you this just a simple highlight, you might be not able to appreciate the use of it. Why not? I just give you an idea of the topics that might be suitable for you to think about. by using this machine learning technique. Of course, I only give you two today. This only the first one here is the supervised learning. Of course, in the machine learning we have the approaches. One is you can use the supervised learning approach. Later on, we will talk about unsupervised learning approach. Then we can mention others like reinforcement learning. So this is not included for my talk here. So it's to make you more relaxed because many of you might be just first time dealing with this subject in your career. So why not I just give you some idea of what you can do about this techniques, the topic that is actually relevant to it. So in the real world example case, there are many research, the past research related to medical image analysis. See the topic about classifying types of tumors in MRD or CT scan, identifying and classifying genetic mutation from DNA sequences. See, so there will be something that you can do about this method, means the research related to classifying, to identifying something, then this method, machine learning can be implemented. Like you see in the finance, credit scoring, classifying loan application, classifying loan applicants as high or low risk based on their credit history and their financial indicators. So this is also a very simple idea that what this machine learning can help you in your data analytics, like customer segmentation, classifying customer into a different segment based on their purchasing behavior and demography. So this is also an interesting topics that you can think about it in your own field, like intrusion detection, vehicle classification, animal behavior monitoring. So this will be an interesting a topic for your research. Maybe you want to do some initial finding or initial research idea that can bring you to a more complex scenario. So you can start with this methods in supervised learning, specifically what we call a machine learning approach that can bring you to better data analysis. So this is the idea, first idea about this. And then I just don't want to go for this label and limitation and advantages. I just escape. So you see, today what I try to do here is with these limited times, I just want to highlight some point and idea as an academic, many of us can start with. Talk about the unsupervised learning. This is another approach in machine learning. So it's actually compared to the supervised learning because the algorithm used now work with unlabeled data, means that we don't know what is the information related to that data. Let's say we want to do some kind of data exploration. We want to know the meaning of the set of data. When I say data, in this case here, with the modern technology and the digital world nowadays, so our data can be very big. So we call big data analytics all the time, in terms of size, in terms of the dynamics, in terms of the dimensions. So these are all related to data with your respective field. So if you are with me now, so you can link or can relate your area of expertise and your case and what type of data do you have, and then what this data is about. Is suitable, more suitable for the supervised learning because you have the label of the data, or you don't have anything solid or maybe meaning of the data yet. So we want to extract the meaning out of it, or we want to do some clustering, or we want to discover pattern or structure with this data. So the machine learning also can assist in this case. We call this as an unsupervised learning. So you can see there are few suggestions for me. For example, patient segmentation, clustering patient based on medical record and health condition to identify groups with similar healthcare needs for personalized treatment plans. Don't you see this topic is great? So there are many opportunity for us as a researcher by implementing these machine learning approaches, then you might able to do what we call a patient segmentation with the mathematical. Later on, we will highlight some mathematics again, the algorithm to you to appreciate. So, but anyway, my intention here is to let you have some idea of what you can do about this approach in machine learning. Like, for example, market basket analysis, clustering product based on purchase history to identify sets of product frequently bought together, which can inform producer placement, product placement, and building strategies. So this can be an interesting topic also. And I select another one, talk about the work-life balance. We can do some clustering methodology about your employee based on their work-life balance satisfaction to identify groups that may need additional support or policy adjustment. So you see, with this data analytics approach, the machine learning approaches, so that you will be able to solve this problem. And subsequently, you can have the idea of this, and subsequently, you can use other methods to enhance your analytics in the later stage of your research. So this is what I try to let you know. And this is visually rich. So it's easy for us to see what this classification means and what this clustering means in the machine learning through the visualization. Of course, when I show this to you, again, there is no shortcut for as similar to many statistical approaches as a research scientist or we are the researchers. So the methods in and data analytics has to be with us. So why I'm showing this is not to let you understand in this short time what this algorithm is all about. But it's just to want to highlight that it's important for you to maybe to take certain class or maybe follow certain very nice YouTube material that can assist you to better understand what this algorithm is all about. Of course, is for us as in the field, in the computer scientist, of course, we need to know all the maths and also know the theory for many algorithms that we are actually need to know as a paper reviewer, a journal paper reviewer. So you have no escape to really able to identify the theoretical reason behind all the models that is actually being proposed. So, of course, for a general interest for as academics, so I would just want to suggest the best way for us to go through this is through a certain module, class, or certain workshop that can make your hand dirty, and then you have the data, you have the software, then you see what you have analyzed. How can you do this in maybe 1 or 2 classes, less than 6 hour class? I want to be able to handle this with some theory about this algorithm. I think this is the effective way how our staff can think about it. One more module is about the artificial neural networks. So I will spend more time later on to talk about this to many of you. And this is what the machine learning workflow when you are in the workshop or joining hands-on data analytics task, you will go through this module, a workflow. I try not to discuss, but it's just want to let you know this workflow is very related to your research methodology. So it means that when you are selecting the topic that I mentioned to you just now, the supervised and unsupervised example, so you will go through what I'm showing to you, means that you have to understand your goals of your research, and then subsequently you have the data, and then you have to do some modeling. In this case, you are implementing the machine learning algorithm into your data, then you need to assess the model performance, and then subsequently you can deploy. when I say deploy, normally we call this is the predictive model that you are trying to suggest. We have something that can predict. If you have a new data, the model that we develop can classify or can cluster into the related group so then for our future use. So this is basically the intelligent part of the AI. I think when I do this methodology, I will just say maybe that is 20 years ago, 30 years ago, and the research has been aggressively presented by using these approaches to many field of studies. So with your field of study, you should also have taking notes, and your data related to your field also has been implemented this machine learning workflow for many research that you can notice in the past 10 years or maybe 20 years. So from now, I just want to make again another highlight for my presentation here is this artificial neural networks. And why I'm saying this is crucial for many of you, then I put this as a second highlight here is, I hope it's like my student, I say to them, I say you have to really go through this in order for you to appreciate what this AI is all about now. Why? Because when you say AI, you say there will be something that is actually learned from something. That means that the machine is actually learn something from human, or maybe it's learn something from the data. So what is means by learn in this case? So the learn in machine need to be highlighted in my presentation, and I hope this will be benefit many of you when you explain this to in your field, when you are using certain AI tools or maybe certain AI packages, when you are developing your own AI modules. So you cannot avoid to explain the learnability components of the AI model that you are actually use. So today I just want to highlight what it means by machine that is able to learn, what it means by learn in this case. So this is actually a bit of the background. So we call a biological neural network of neuron of human being. I try not to put it in a difficult context for myself. I am not an expert in this field, but basically we still can see some simplified version of our nerve system. We have the dendrite that will be actually as a receiver. The signal of some neuron will be received by our dendrite, and they will pass to our cell body, and subsequently they will emitted through our axon. So they will be received, processed, and then emit this kind of mechanism that is actually happens in our neuron. And of course, this model has been suggests long times ago with this cognitive psychology. Psychologist Donald Happs in 1949. So his suggestion is why not we have some idea how can we conceptualize this into artificial neural nets. So we want to do something, hey, can we do what we call connectionism, so that we want to bring this as some computational model that can benefit us in creating the behavior of this neuron. And of course, this is very famous HAP rules suggested by him. I try not to really highlight this, but it's important for us in the cognitive science and cognitive psychology field to know what this rule is all about. And for what I try to highlight in this case here is will be some inputs, and then there will be some processing part, and then there will be some output out of it. So in mathematics, I want many of you, and you will see why I'm selecting this topic to you. Never mind, you just follow me some process that is actually important for us to know what this learning mechanism that happen in machine. So why machine can have something what we call learn is because of these simple operations. Why? This is very simple because it's just, we don't have any very difficult mathematical operation that I ask you to learn now. It's just multiplication and then addition. Okay, that's all. So And this simple model, when we connect it into a multi-layer, a multiple neuron model, it becomes a powerful function approximator. So this is a bit mathematics. But never mind, what it means by here is this model will assist us later on in a learning process of the AI system that you actually observe nowadays. This is just a simple one neuron. And what this mechanism is, I want to force you to learn a bit, is we have what we call the W parameter, which is the variable. This W can change. And the input cannot change. Means, of course, what I'm saying here is input is from you. So you have millions of data. So you have the data that you want your AIs to learn. So then you have your data that used to train the AI system, isn't it? So what I say here is the data no change because it's from you. But what is actually going to change in the system here is the W. So surprisingly, when we have all this operation done, so the W will be updated. Later on, I will show you what we mean by update. But we appreciate, we go through the operations first. So this is what the mechanics of the AI that need to be known by many of us. In short, let me put it in this way. So we have a multiplication of these two numbers. So 0 and 2 is actually multiplied. We have 3 and 1 is actually multiplied. And we put all together in the summation, means we sum up all. We campurkan semua. We sum up all with another variable we call bias. Bias term is just offset for our neural networks theoretically, but we don't need to explain in this short presentation. You believe me that we still have one number system. This is a number, it's not variables, W. So we have the number B that need to be summed up together, and then we put this into activation function and F, then we get some number out. What is this F2? For many of us, we just say, hey, may I know what this F function is all about? In many neural networks, mathematically, we actually want to explain first the simodal function according to this equation. And I try not to elaborate more about this equation, but from the graph, you will be able to easily observe. Let's say I have a 2 over here. So look at the graph 2, then you look at the blue color line, then there will be an intersection here. It's actually 0.88, 0.881. So you get the 0.881 as an output for your neuron. So I repeat. So a single neuron is like this. We are actually multiplying your data, in this case, your input, with the weights. So we have the line, weights over here, and then we sum up together. Do not forgetting, we have the B over here. Then we go, before we go out from the neuron, there will be some activation function that you have to taking care of. Then from then we get the number. Okay, good. So this is a simple mechanism. Of course, with this short time, when you are first time with this, you might have to again remember this a bit. But for me, to assist you, we need to build our neuron, not only one, but we want to build many neurons, layers of neurons that we will be able to use this effectively. So the operation is exactly the same. Means that we have the input for many input go to the neuron, then we have output just now 0.88. Similarly to the second neuron with the different weight values. So we have output of this green colors number, and this two number will be multiplied with another neuron. So when we have a neuron, we need to have the two weights. The weights W is the value that need to be found in your ChatGPT. So when I'm talking about this model, I say it's very relevant to what you are actually use all the times and who train this model. So the OpenAI's research team train the model, then we use. So what has been kept in the model why the model is so big, why people say this is actually a huge a model, a large language model that is actually used by many of us. What it means by large in this case. So the model itself must have a lot of W. If I have time, later on we will explain this more detail. We have a lot of W that need to be learned, need to be adjusted. Then we will be able to use this when we want to use the model in the operations stage. So when I say change the W, up to now, we never change W. We are just having our X and then we have our Y. W never changed. You say, where is the mechanism of changing the W? So far, we are talking about the feed-forward direction. This is terminology again. Feed-forward means that we have the data, like what your ChatGPT are using. You have a language somewhere around here. Then the ChatGPT need to give you then the answer out of it. So this is feed-forward in operation, means that we are not doing any training, means that the ChatGPT has released this to us to use. Okay, but before the teams is actually develop this, they need to train, they need to adjust the W's so that they will give you a proper value of Y. So give you some idea of what this is all about. Theoretically, again, just give you some idea. So in order for us, this one, again, related to Max. And this is also important for you to explain to your student. So we have a feed-forward mechanism, means this is in operation. We use the model, but before we use the model, you need to inform your student also, the model has to be trained. There might be something that need to be obtained. Your W's value need to be obtained through a training process. This is the theory behind it. Of course, this is not really an interesting topic with this short presentation. But the idea here is we have to do some kind of derivative. Okay, if you are familiar with this okay. If don't, never mind. In the layman term here is we want to minimize our cost. What is actually our cost? Our cost here is the expected output. So we have the input. The model will come up with certain output, Y predict to us. So do you think that this Y predict is near to the target? So if I want it to be 1, but suddenly give me 0.52. So this is the cost that you have to take if your W is not properly trained. So we want to minimize this according to derivative procedure. Here, there will be a change rule for us to appreciate. I try not to give you details of this part. And I will attach a document if you need my slide later on. So that document will have a very good tutorial about how can you calculate what we call a back propagation process. This back propagation process is the process of updating our W. So we have just now we say our feed forward. So when you look at my mouse, we feed forward. We have the data, we have the W value, then the ChatGPT will give us the answer. So, but beforehand, how can you know this value? We have terabytes of size of the model that you have to learn. So we have a lot of W that you have to learn. So how can you do this? How can you update your W automatically? It cannot be by man. It must be some approach for you to do this automatically. This approach is called back propagation. So through the error of Y, we will be able to find backward. Of course, is true. Again, the tutorial will highlight what it means by the derivative of this one by one until you get your W done. So in short, so what I want you to take notes here is the ChatGPT are actually doing the training before they let go the model to you. Let's say we put it in the layman term. So what is actually what they are doing here is they have a lot of information. All you know, there will be just the text from all around the world. So we want to update the W. So when you look at all the lines over here, it's about the W value. And then they also have some kind of what we call desired output if they are using supervised learning. It might be not necessarily supervised, it can be unsupervised learning. Then you have the way how you adjust the internal parameter conceptually. But all the detail is, of course, more than what I mentioned just now. This is what we call the training stage of the machine. So we want to train the machine. It's actually what we train. What has been happened in the machine is actually to update or to get all the W value. Later on, we will discuss more. Again, with the respective model about the train ED model. So when the train model has been completed, so in operation, we want to use this for a general public. So then you have the new input, then we will have an expected or we call estimated output that you might have to see. Why this network is able to come up with this intelligent feature. So it's because of what we have completed just now, a simple neuron mechanism that I mentioned to you just now, a simple operation. Again, I cannot do this in this short time of presentation, but it's just so simple like this. And then we will have the result, means the promising result that what happens in nowadays. Of course, this model is not new. So to talk about this, maybe the operation of neural networks has been in the past 30 years. But why this now is become so famous, why we have the large model is, of course, there will be two factors. The first factor is with the internet technology, we have massive data in the digital form. So people can use this information for training purpose, means the data is already available in the digital form. Okay, so this is the booming of the internet technology nowadays. And second one here is the hardware technology. As I mentioned to you, so my background is actually in the computer graphics. So we are very familiar with the pipelines and parallelism that need to be incorporated in your graphic processing units long times ago, when the NVIDIA is still a small company who are actually giving us a suggestion of the graphics processing card to enhance your GPU. So now to become a giant and famous company is because of the operation of our neural network you see from here. It also can be parallelized, means it actually can be put into a parallel operation. That is actually an advantage, again, like a computer graphic, when we are talking about the pixels operation in the graphics. So we also can do the parallels algorithm. So this is very related, and we are actually quite happy with the innovation of the graphics. And this is also the innovation of the neural networks. Actually, these both things can be linked together. So this is the second part of it. Of course, the minor part also the creativity of several researchers who have been proposing a deep learning model in the very beginnings, how we can process and recognize images. And then subsequently, we have the transformer model and become a very interesting feature for us to use. So this is what you have to appreciate with. Of course, I don't know whether I still have the sufficient time for my demo or not. I have been mentioning this for long. Means that I say the neural network can do this and can do that. So why not we have some demo about this? But I think maybe with a population of the participants in this online, the network might be not able to show you the real-time demonstration. Why not I give you a try? So let me switch to the demo site. You see my screen, the new screen now. I need your response. Do you see my new screen now? Anybody can respond to me?
Yes, we can see.
Yes, thank you.
We can see.
Good. So why I'm showing this to you is most of the Earth is we want to see and then we believe. Thank you. Yeah, thank you for your response. I want to see, then I can believe. If no, then why you say something that we cannot believe? So why not we see something first? So in this simulation run, I don't know whether it will be a real-time display on your screen or not, because due to the participants, and it also depends on the networks that you have. So what this simulation show you that we have the input, and then we have the neuron, and then what will be the output from this neuron. So we have a simple task for you to appreciate with. We have a two group of information. I want to separate these two. Why not I just run? So can you see the animation? But maybe in your computer, the latency might be not really appropriate for you. Never mind, I just want to let you know, we see that there will be some simulation is actually happening here. And then we will be able to do, hey, the neuron is able to do a classification task. At least we say the neuron is able to learn from the data, and the neuron is able to let you know we can separate your data into two groups. From a human perspective, no problem. We know what is the orange color and what is the blue color, but how the machine do this? If I have a very difficult data, let's say, you see the data is in such case, for human being, it's no problem for us to draw the line to separate these two groups of data. But how can we do this automatically? By increase our neuron, and then we continue our simulation run. So we hope there will be some formation of the boundary that is actually able to distinguish the data, if you can see the simulation properly. Of course, let me go back to my slide. So what I'm trying to say in my slide over here is, it's just a simple simulation for us to appreciate the hidden layer, the meaning of the hidden layer, in this case, the neuron that you are actually defined. If we have more, what will happen if our problem is not linearly separable? This is not easy for us to come up with this boundary through your mathematical process. If you want to form a math derivative about this, is quite challenging for us. So if we have a more difficult problem for us to solve, how can you solve this problem? I want you to be able to distinguish these two patterns, so we can increase our features, or we can increase our hidden layers. I want to bring you the notice here. Means we have more neurons, seems to be a good case, but sometimes more neurons might be not able to solve the problem. Also, we want to increase the input. Instead of x1, x2, we want the power of x1 and power of x2 as an information to our neuron. So this is the point I want to bring again later on when we talk about the deep learning process, and then the large language model that can process your text. So then our feature in this case will be a very interesting discussion point. Not really the neuron, it's actually the feature that we have to mention. Okay, so basically what I try to show to you here is, believe me, the neuron is actually, the network is actually so powerful that is actually can bring you, we call a function approximator that can approximate all functions that you can derive with in your real world case. So this is the very important mechanics of the AI that I hope many of you can appreciate with. Okay, so basically, in short, what I try to project here is, hey, we have to know there will be some point in the operation of the AI that the learning ability must be there. We want some mechanism of the mathematics or the procedure that I just mentioned to you that is able to learn something from our data. Either we will be able, after learning, we will be able to form a classifier based on the red line. We have the data of such, so we can have a line like this for a linear case like this, or non-linear case like this. Also, we can ask the neural networks to learn. So this is crucially, I repeat, for many of us, if you have times, maybe you can, again, go through several tutorials that will benefit you. Again, because of this very short presentation, and then you have a solid understanding about this neural network is all about. Okay, so this is a suggestion to you. Of course, when you are doing it, means you are already practicing and doing it, means you want to develop something out of it, then you will face this challenging also. Like for example, generalization, underfitting, overfitting, and this also will be some knowledge that you might need to know later on in your class or maybe in your workshop related to this. So I try not to mention, but some notes also need to be given to you. I think with very limited time, I still have another 30 minutes to go. I hope that you are still with me. What our intention here is, why is actually happening now? We have the ChatGPT that is called, it's a large learning model, LLMs. We have a graphic generator that can generate many creative image for us. There will be a text-to-text translation. There will be a voice-to-voice translation, languages, I'm saying, in this case. So what is actually happening in this field? So let me put it in some category out of it. So the point here is we classify what I mentioned this into what we call deep learning. So again, when we talk about large learning model, so it's also a deep learning model. Of course, as I said, we have our neural networks, right, that we learn. We already mentioned just now. Okay, can we do something about it? So we can rearrange the network. We can restructure the networks. For example, we have this restricted Boltzmann's machine. We have the autoencoder that has been very famous. It's been used for a diffusion model. It means that the model that is able to generate your what we call a deep fat model. And then we have a very nice neural network model that can perform a very good pattern classification task. We have the deep neural networks model that is actually implemented in our transformer. We have the recurrence neural networks. With this type of behavior, we will be able to generate the sequence of text. You see, text can be generated sequentially. So if you are expert in language, to construct a paragraph, so it means that you are generating some words by words from the left to the right, and then subsequently from top to bottom. Then you generated a paragraph. So the recurrent neural networks are able to do this. And when you look at the arrow pointing of this, it shows you again the input for the first one is only one, but for the second neuron there is two. Can you see? There's a one input here and another one input here. And the third neuron also, you can have another one input here, another one input here. So it's actually quite an interesting feature for us to look at. Means that it's a sequential process. We will have a first one before we can get the second one and the third one. It's like a language generation. I say machine, not human. Means that if you say deep, so what will be the next for deep? Then subsequently subset. So this is basically an interesting feature for our transformer later on if we have times to go through. And another one here is your reinforcement learning. So it means that we have to train our transformer so that they will be able to answer your question properly. And you cannot just let the machine do everything they like. You have some kind of feedback from the evaluator. So before the model has been developed, so there will be some testing parts given by the response from the anonymous user, the feedback from the anonymous user to range the answer generated by the transformer, whether which one is the best, second and third. So this, what we call again, the reinforcement learning can be taking place. So for many of us, so when we say, I want to know about this AI. Do I need to learn all this stuff? So no, and yes. So I will say for first person who, for you first to join, want to explore the opportunity in this AI developments, not user. So if you are just a common user, so this mechanic might be not really relevant to use. But if you are in academics research, you want to able to justify and explain to your user your fields of study why this AI assistant will be giving you this kind of response. So whether this response will be accurate and what type of modification that we can deal with. So I'm talking about you are with your AI assistant and you know what your assistant is actually doing. So for the certain extent, you have to really go into this network with proper guidance. Again, as I say, maybe 1 or 2 workshops will bring you understanding about this. Okay, so for me today, I just want to highlight convolution neural network. I think I have no time. Let me go into the model. So the model always present in such a way. So as many people in non-technical, so we don't like to see this. So many layers. Also, what happened in this case and here and there. Why not I just let you inform? So it's nothing else. It's just a very simple process. In the first few process over here is to extract our feature of our image. And the second part of this model is what you have just learned just now, the artificial neural network with multi-layers. Means not only just 1 or 2, but it can be a dense neural network model. When I say dense, means it's a lot of neurons, a lot of layers. Okay, so when you look at here, means hey, I have 1 input, then go through this process. I want this toward the end of the day, I want a number that can be used by our networks. Can you tell me what this green number, I say the input part, let's say I have some number over here. When I put it into a number as an input for our neuron, can you tell what this number? So this is just a simple like this. In the convolution process, of course, if you want to really go into the max of this feature extraction, maybe you might take another 2 hours with your computer science lecturer to really go into this. Then in the details, at least now you know, hey, how can I come up with this number? And then subsequently, I train my network. So later on, when my network is able to train, as I mentioned just now, so you will be able to know this is 2, then 2 will be the output for the networks. So this is as simple as like this. Of course, I say conceptually, and in visually, we want to see something happen. What happened in this convolution neural network? I give you something to see. Let's say I have a car. In the low-level feature, maybe in this beginning of the process, we will have something like this to represent the car. Of course, this is in the low-level feature. Of course, you know, a car is not as simple as what you just input the car, put the car into here, then you do the matching. If you have a new car coming, then you see how similar this car with my database. I think you cannot do this anymore. Means to search from your database how similar a car with your database. This is not really the proper approach. Well, a good approach here is we want the feature. So you subsequently we have the feature of the car. I don't know toward the end of the day, don't know what is this. Yeah, the important here is number. I want a series of number. Later on, it can be an input of our neural networks I mentioned just now. Then the neural network that has been learned. I said before you use, you need to train the neural network first. So what I'm saying now here is when you in operation. I have a 2 over here. Can you tell me 2? Yes. Then at least your neuron in operation can give us this classification. And this is a very successful model. And it will be just a kick-off point for many deep learning model. And with this initial idea, I think maybe this is like 15 years ago with a very successful neural network that can classify some more than 1,000 objects. This is the milestone in the deep learning in AI, I would say so. And with the development of these similar methods, we have even improved this for real-time object tracking. Again, the detail will be not given here, but I just want to highlight nowadays it's not about to able to facial recognition. You can recognize your face or your friends or your student for attendance purpose. So this is just a very simple task. Nowadays I say simple because of the solution that we all know. But even now we can go for a real-time object detection with a very limited information about objects presented in your videos. So you can imagine the potential of vision AI in the near future. How can you implement this with limited and fast changing environments? And the detail of this also will not be highlighted. But if you are really interested to go further about this real-time detection, I would suggest you to go again in this field. So you try to understand what this YOLO is all about. So what is actually, in this case, I'm going to stop. So the first module, I just want to let you know about deep learning here is it's not that difficult. It's the first part here is we want to turn or change the picture into some series or number. And this is the convolution process. If you want to further go into it, yes, you can. So this is for image. How about words? So we have words. So we also want to do the same. We want our words language, English, Bahasa Malaysia. So we want to turn this into a number. So this is the purpose of our task. It's not about the network. It's about this part. If you know how to turn your gesture into number, if you know how to turn your robotics movement into a number, if you know how to turn the environmental parameters into a number, then you can create an AI system. So see, I coined this, take all the responsibility of what I'm claiming. So the point, what you can see from here is we want our words that can be a meaningful number, at least because language is not easy. You can see the bank that has been used in English sentence. You want to go to the bank. You want to pin it on the bank of the liver. So the pilot bank, the hospital has large bank of donated bloods. So you see, this is very challenging, isn't it? So how can we do so? There will be some point that again, just a simulation for you to understand how can we turn at least to a words to some number for our neural network. Again, I just want to highlight this is just some idea that you might be able to explain to your student later on in this what we call words embedding. Okay, so let's say we have a two sentence. Durian is great, orange is great, durian is great, and orange. So these are all the words. I want it to have some meaningful number that can represent durian. Of course, it's not that simple. Of course, we know the durian itself can be a very difficult words in many contexts, whatever. But we just want to simulate something that we can do about it by using the neural networks. So what we can do here is we put the first input is durian. So we use this as our input, and the expected output is because I will say our word is durian is. So the expected next word will be is, isn't it? So we have the input, we have the expected output. So what can we do? We can train the network. So we have, again, after is great. So this is the second part. Durian is. After is what? Great. Okay, so we can have another one. Orange is. So we have that orange, the subsequent word is. So you can see we can do this type of simple annotation, a simple matching, see how we can train words in such a form. I have been simplified this to let you have a comfortable understanding. Of course, there will be actually more than that in a certain detail. So when we have this kind of matching, we can do for the first time when we input our durian as 1 to our networks. So the output is 0.55 for the output is. It's not really good, isn't it? So we want to improve what? Improve the weights, as I mentioned just now, the W. That is actually still random in the very initial stage when you have not yet trained any dictionary or any text to your neural network yet. So the result will be in such a way, means the result is not good. So we want to, again, to do the weight update. So you see, toward the end, we want to do a back propagation process. Simulated one more time. So we have nothing now. We have 1 input and output. So this is what you see. Then subsequently, so we have this input and this is output. This is the input. This is output. And then we start to train our neural network through the feed forward process. First, for the feed forward process, we obtain the number is not really good. So then we back propagate. This is also where we have already learned just now. We want to, based on the expected value and the error that is generated by the networks, we want to use our back propagations formula to update our weights. So you see, this thing is going up and down, up and down, no up down, go to the left and right, feed forward, backward, feed forward, backwards. So toward the end of the day, we will have some value learned from this connection. So we will have some value that can represent durian 0.34, 0.440 means after you have asked the networks to train many, many times. So in short, what we can see, let's say, a good news here is, let's say we have all this number trained by the neural networks, and then this number is actually meaningful if we want to plot it into, let's say, in the 2D dimension. So the durian should be somewhere around here, the orange should be somewhere around, because what? Because they are fruits, let's say. The meaning of the context of this word will be an appropriate for us to put the value into it. Of course, in the real world scenario, it's not that simple like this. We just jump a bit. So for a total number of weights, in this case, deep learning neural network, you can see an entire Wikipedia is used to train the deep neural network. The vocabulary might up to 3 million words and phrase. Thus, the total number of weights in neural network can up to 600 to 700 millions. So, so you ask me this question. So can we train our Bahasa Malaysia in our own context? So if I want to train our national language into something like this, means we give you a durian, you give me a series of number. If you give me a rambutan, you give me a series of number. Can you do this for our national language? So this is again some point that I just want to highlight. Again, so when we are actually involved in the AI scenario, so there will be some concern for us. What kind of resources and investment that you want to put in order for us to have our own against a model of our AI. Means, let's say our own ChatGPT. Own is the language is actually based on our dictionary and based on our information, our local information. So it is quite an interesting point for us to look at it. So, but what I know here is there will be a company out there, so that will be just providing you the service of what we call an embedding. Means you give me a word, I give you the number. You give me a word, I give you a number. So why this is needed? Because you don't need to do this training. The words and the number has been trained beforehand by the company. So they are actually service what we call the embedding service to you. You have the input, I give you the number. Okay, so you have something that you want to turn it into number for your AIs to learn. You refer to us because we have trained the model. And why they can train the model? Because they have the sufficient data for doing this. Of course, when we talk about this large language model, I'm almost end my presentation in another few minutes. So I don't go for the details, but I know if you all know that there will be just very high parameters. Say now, when I talk about parameters, then you have some idea now. It's actually the W's that we are actually means. What we are actually interested to know is, hey, can you give me that parameters, the value of W? So the open source like Llama in this case give you the parameter up to 140 dB. So if you have some kind of intention to go further about this open source large language model, you can consider this open source. Let's say the Llama version, the name of the large language model with 70 billion or 100 parameters in this case. And you can have a lower one if you have limited resources for you to want to try to hands-on, or you can fine-tune, or you want to adjust what this large language model is all about. You can have the try. But for us, when we are talking about this in OpenAI, GPT-4 might have the 1.7 trillion parameters. What I'm saying here is the W that I mean. And for you to run the code is not really difficult, because even the open source give you the 500 line of code, C code, then you can have your model in place. So but the issue here is what is this actually? So before I go into this detail, it will be not really an enjoyment process for me to go one by one. And it's just some highlight that I want you to take notes. And then when you look at this model, you have something to mention to your student, at least a conceptual level. If you want to go into really details of the arithmetics, means the operation step by step, so the link has been provided. But when we look at this, what is this actually? So you can see we talk about this large language model, and then always people showing these two tower, tower left and tower right. You have the encoder and the decoder, this kind of stuff. What is actually this means to us? For a layman, we say, hey, this is nothing, just something that you have to take notes. We have a neural network model that is actually learns something about it. So learn what? So before the model is actually deployed to you to use, let's say this encoder decoder model is good for machine translation. The source is Bahasa Malaysia. Saya pergi ke pasar. So the output in Bahasa English, BI is I want to go to market, for example. So this is good for a machine translation model, encoder and decoder model. But sometimes in many model, others model, maybe not necessarily, we can have text summarization. So maybe text summarization, we only focus a development of encoder only. So we have a long text. I want to know the semantics of this text, the summary of this text. I don't need to do the translation, isn't it? I just want to do the text summation. So we can only employ an encoder model. Later on, I will explain what this model briefly to you. And if I want to do a text generation like a ChatGPT, so I don't need a translation process. Let's say I have a very short text. I have a query, answer, or question to the ChatGPT. Can you solve this assignment for me? What is the main point that need to be putting into my assignment? Let's say. Oh, so then you have all these words query to your ChatGPT. Then the ChatGPT later on will give you the elaboration of this. But it just continue. What is actually the elaboration means that we just elaborate based on your question. Even the decoder don't know what your question is all about. is no connection. There is no intelligent, or say cognitive component that is not in this neural network. It's just a number, as we can see from my presentation just now. You have the number as a feed forward, and then you have a back propagation to correct this number. Where is the cognitive component over here? Where is the thought over here? Where is the intelligence over here? It's just not really in such a case as compared to the human being. It's just a mathematical operations that one day, because of you have huge, a lot of W's, then I can do something for you. Okay, why not we just go into the yellow boxes, what you can see over here. So these yellow boxes, in a certain extent, are all neural networks models. It means that they will have some embedding, just now I told you already. So I have a text, turn it into number, but text is difficult. Just a number is not sufficient. We need to know the position of the token in this word by words. We want to incorporate the information of what? The location, the text. Let's say this architecture consists of an encoder. Let's say 1, 2, 3, 4, 5, 6. You have 6 words, we call 6 tokens. So can you tell me where is this token? Where? Location 1, 2, 3, 4, 5, 6, and etc. Let's say in such a manner. Of course, it's not that simple. We are using the cosines formula to identify the position, which is much more efficient. And then we have a model. Again, this model is a neural network model with our Q, K, and V value. And again, when you go through this process, if you have been learning this model for several times, but you still don't know what this QKV model is all about, so maybe later on I'll give you another link for you to appreciate with this. Of course, it's another 30 to 45 reading times for you to really appreciate what is QK and V model means. In this case, we want, in a layman term, I want not only the meaning of words, but I want to know even the location and the context of these words. Because when we capture a sentence or paragraph, we have different facets about this info, especially language in humans, they use by humans. It's not that simple in such a way. So we have to do some kind of calculation, in this case, to enhance our number. So again, we have a number over here. We have an output number over here. So again, when you look at this, FFM means the feed-forward neural networks. So we have a good neural network at the top of this encoder, so that we will have a good meaning of our input. I mentioned to you just now about the graphic. We want to convert our image into a series of numbers through the convolution process. That's how I mentioned to you. It's a similar thing. We want to convert our words into a series of numbers. Hey, this number is a very long vectors number. It can up to few thousands. It's not 2, 3 number. It means the sum tokens, words, need to be represented by a long dimension vectors. So only then we can capture the semantics of this word, so that we can train our networks, in this case, that again able to perform the classification later on in a better manner. So this is the first module that I just want to highlight. And this thing also happened in the decoder, but the decoder has a different characteristic. Because of, you see the model has several link and here, link and there, so we don't go into that link yet. So it just want to let you know, if I have a words, I want to generate another words, and then subsequently generates another word. You still remember just now I mentioned about the recursive neural networks in my previous presentation, the slide I don't want to forward. But no, we are actually, the output of certain networks is actually the input for another networks. So we are recursively, if you know the words recursive, we are recursively to generate the next word for our model. So in ChatGPT, they don't know what will happen. It's actually not like human. So when I'm doing this presentation, I have a lot of connective processors behind me because I want to say something in between and in front or before. So I have the connective processors happen in my in my mind, in my brain. I don't know what happened there. So cognitive science still not really able to answer this properly. But not talking about this system even don't have this anymore. They just to make sure you give me the previous input, then I generate the next one. Okay? So then the next one is from what you have been generated. You give me all you have been generated, I give you another next one. So it's just a recursive process that's actually happened in here. So you can see we have the loops over here. We have some points to train our networks. We have targets that actually going through against the attention mechanism is also a QKV's operation. If you want to go into details, means we want our words to be meaningful enough into a representation of series of number for our networks. And subsequently, then we want you to generate more sequence number for us in a multi-hits attention. Means we want not only one facet, but I want to duplicate the similar process in multiple neurons. So the depth in this case you can see here is we have 6 times 6 means we are actually implements parallelly 6 neural network in such a model. So in short, I just want to let you know for this decoder model, you can see the target is actually from the previous step. So this is the recursive nature of the decoder. So the decoder need to take the input from our encoder because, as I say, encoder-decoder process is machine translation. So you have a BM, so I need to feed the English. So how can I know this? What kind of next words that is actually appropriate for the English words? So it's actually through your multi-hits attention and then go back to our networks that is actually have been trained beforehand how to do this translation. So you have the words about BI, then and you have another document about our BM. So then this thing need to be able to learn. So when I show you this model, I always position myself as operation side. Means we have the source, we want to have the output, but not to forget about it. We have a training phase. The training phase means that you don't know the output. So what we have here is that we have a mass input and output relationship. The documents, it just fits to the network and asks the network to learn it by itself. So this is what we call the unsupervised learning processes. The learn process is not showing in this case. And to discuss about the learn process is not that simple. Even according to my reading, what I try to find here is not really able to release for us to appreciate how this learning method has been in place. I say in detail. So basically, we have some idea about what the neural networks has been backpropagated according to the error and the expecting source and also the expecting words, and then we will be able to see the error of this part. Only then we backpropagates to all the models that is in this transformer. And this part is still, for my knowledge, I still have not really able to appreciate this, but basically it should be in such a way. So to let us into a more intuitive way, we have basically know what this encoder decoder is all about. But many of us to say, hey, can I have a change? I want to use your model, but use my own data. I want to find to certain extent to configure, not to say fine tune, configure your networks. It's possible for me to do this or not. So of course you can have so many API for means application programming interface that offered by commercials large language model for use to use. But the point here is for us as an academics, normally we prefer some kind of open source. So LangChain has gains. If you can think about it, people also can think about it. Means what you want. So people also give you an options how you can enjoy your experiments yourself with this language model. So for us, most of the time, I think basically when we want to develop, we cannot do this at that moment with our resources. I say already a general model, a general AI, we might have the difficulties to do that, but we still can, again, with certain open source, we can do some configuration based on our own knowledge. So the LangChain provide you with this kind of mechanism for you to able to embed your own documents. You can see there will be some mechanism for you to upload your PDF, and then there will be some automated embeddings and mechanism, turn it into number and put it into your knowledge base. It means your local, maybe your local servers, or maybe your localized the database management system, so that we can again to generate ranks result to our LLM model. See, the LLM model is, let's say you have the Llama or big models, that you are not able to do this training by your resources, your group of people. So we have some open source for you to implement this into loops. So at least you will have some localized context for your question and answers mechanism. And then you are still keep the general ability of the large language model that can answer a general question to your user. So to repeat this is to say that, to conclude a bit of what I'm trying to say here is, it's not really and easy for us to really to reconstruct your own LLM. It's not to say cannot, but the resources we need to really consider. But we have a chance to incorporate our model into an open source. I'm not talking about the commercial API that you need to pay for. This is not in our discussion. This is you just use as an end user. You don't know what is actually happening there, but you just use. But for us as a university, I will just encourage in the near future, we will have some option that you have your own AI assistant that is actually locally built. So this is the intention that you should have to taking notes. So there will be some cases like you have to want to develop in your own field, literature reviews assistant. If you say there will be some free model out there, you can have a try. Then you can use that for your literature reviews process. You can have the interactive learning module. Maybe you want to generate some learning activities. Then you can have this module in place. I'll just give you some idea of it. So to conclude this, I just give you a very short summary of what my presentation is. Actually, my intention here is, again, to share with you. So with my limited experience in this area, what can we do and what kind of preparation should we have as an institution of higher learning, especially a researcher, a teacher, a person who want to serve our communities, who want to be leader in our own field with these developments of AI. So what can we do about it? Some kind of thing that can be our highlights. So just some kind of implementation form. I'm just giving you just an overview of what we can have in our own responsibility, means based on your own priority of your career or maybe your research interest. So we can have some infrastructure maybe offered by your university, or maybe some commons shared open source resources that you can acquire out there. So as an academician, maybe we have to go through several process. Like today, what we are actually doing here is give you some key. I hope I can do that, and some idea about what this machine learning is all about. And there are many modules that later on will be presented by our subsequent AI's webinars, expertise from various perspectives, who will be the user, developers, or maybe they are a person who has been doing their data analytics successfully, use cases that will be shared through our this AI webinar. I hope that you will be able to enjoy and follow this in order for us, again, the change that might happen in our learning and redesigns. We have need to reconsider your research and innovation by taking into AI as options, and of course not forgetting our administrative process in the university. So this is basically what I would like to suggest. How can we play a part in this process of the change of the AI? And the samples, some key knowledge and tool, I hope I can distribute it properly, is depicted in this diagram. So we have the administrative who have to know some skill and knowledge about the AI literacy, like the talk for today. Hopefully I can help. It's not only up to the user, because you use, but you don't know what happened out there. As I mentioned, this is not you use the Ellipse system, then you just put whatever slide you ask for the quiz, then the Ellipse will just respond accordingly. It's just not like this. It's not an information retrieval system anymore when we talk about the AI. So it should be more toward that, more than what we actually know. So it means we are dealing with something that will have some general ability, like what human being, I say, the intelligent part, certain extent, okay, that can respond to you with your input. So if you input something, there will be some response that is out of your expectation. Can you tell me why? So this is what happens when we are talking about the AI processes that can bring you to a certain efficiency of your administrative works, but you still have need to have the AI literacy about it. So the knowledge like productivity tools, data preparation, data interpretation, and of course the ethics and the privacy issue, that for the administrative need to be able to handle. So these are all some suggested tool that if I may, to give you some kind of view for the administrative process. Of course, with our AI hubs and our initiative for our training module, like what we are observing now, the CAM, and we have the parties who are providing the proper training for administrative, I would like to suggest there will be some, again, the AI literacy need to be in place, and the ethics and privacy issue of data handling also need to be in place when they are talking about the requirements and key delivery. So for our strategic part, so there will be some optimum knowledge, scenario planning process that need to have, and then will be some kind of the useful tools or techniques that need to be known, but like for example, data analytics techniques that I mentioned just now. If you have knowledge about what this technical stuff is all about, then only then you know what the conclusion is actually drawn by the tool that you are actually use. So you should have been able to do that. And subsequently for our academics, as I just want not to try to mention, and you can see CAM is organizing this, and the RIC is also proactively promoting the use of AI through the AI hubs for us to incorporate our research methodology or research in the AI arena. So I think this is basically my presentation. I think sorry for just a very long one, but I try best. Okay, thank you. That's all for my presentation.
Okay, thank you very much, Associate Professor Dr. Teh. So basically, some example of
I cannot hear you.
machine learning applications.
Okay.
Yeah.
Can you repeat the question? Yeah.
Oh. Is someone asking question or?
Yeah. No question, huh? Okay.
Yeah. So yeah, basically he shared with us all those AI things and then the possible research area in AI, the technical part, okay, the classification versus the prediction model of AI, supervised versus unsupervised models, algorithm, okay, and he shared with us the large programming models, large language models, okay, so some example of AI tools that he's been using, okay. So now is the Q&A session. We have more than 200 participants today. Okay, so we are expecting some question now. Okay, any question from the floor, please? Please, you can ask question by voicing out or you can type in the chatting part. Okay.
Yeah, I get your question from Ting Li. From the chat, I just directly answer. So this is a great questions. For example, what are the minimum requirements needed before the analytics? So I will just want to suggest, of course, there will be just for a beginner. So of course, there will be some algebra that you have to know. So I think this is very common mathematical knowledge that you have to know what is the matrix multiplication and at least of what's related to vectors, this type of operation. But the operation is quite straightforward. So I will want to suggest our workshop have to be in place. It means the university will, based on expertise. Of course, I'm the first one, but later on you will see there are many experts in the field from ITs and engineering faculties. So we will give you some idea of how can you start with this. And to talk about the requirement needed before the analytics, or what kind of software that is recommended for this study, I want to divide this into two parts. The first part, if you want to have full control, of course, there will be some programming skill will be very advantageous. This is first part. So means if you are engineering related field, and this is surely not your problem. So another one here is if you are not in the what we call so-called the technical aspect, I'm not really enjoy this kind of coding stuff. There are plenty of software that you can start with. Means that there will be some software like Orange. There's some software that is actually can be useful for you to start with the data analytics process. And as I said, they will be encouraged. I would strongly encourage you to go through the proper workshop, maybe attending one or two sessions, and then with tools that will be suggested by the instructor, and then is to give you the guidance. With these limited times, I cannot give you the real example, what is the pro and cons that you will get from this very user-friendly software. But through the workshop, you will be able to appreciate this better. Thank you for your question, Ting Li. Yeah.
Can I ask
Any
one
other question, please? Yeah.
Yeah. Okay. Thank you so much, AP Dr. Teh, for the great presentation. I have one question. Like every technology has positive and negative aspects. Currently, about the AI and especially the generative AI, many people are talking about its usefulness. But what do you think? What will be the possible negative effects, on, especially on human life?
Yeah, thank you, Dr. Rehman, for your question. So I try not to position me into that. So why not you just go through my first presentation? That's why I introduced to use the ethical issue about this AIs for the societal perspective. This is the very a long discussion about different view from different parties. But I just want to suggest for what I try to position to this group here is, this is no harm for you to know what is the mechanism of the AI. There is no harm for you to know what is the methods that has been implemented for these AI developers or the software that has been produced for use to use. Okay, so this is some minimums that I'm asking for this group to agree with if. And then subsequently, then you can only position yourself into this type of debate, the pros and cons about this. From the user perspective, there are many perspectives that we can talk. There is very difficult for me to really answer your question because I cannot be generalized. I have limited information to generalize. With the observation that you can see for our teaching and learning, even from the institution of higher learning, like what we face now, the pro and con can be clearly observed from the student learning activities and also the instructors who have to redesign their learning teaching learning approaches. So sorry to answer that because for me I think I have not in the position to really able to answer this whether what's the pro and cons that is actually happens for this the ChatGPT. Okay, Dr. Raymond. That's why
Thank you so much.
we need more discussion. As I show to my first slide, I say the discussion is still ongoing, and then the philosophers and the AI experts are in a better position to let us know the consequence out of it. Yeah. And we have the second question from Seping. So we have many applications offered by the different AI techniques, but what would be the infrastructure needs to run the software? Is it needed for the institute to invest this infrastructure? Yeah, this is interesting against for the question posted by you, Seping. So it's a cumulative decision. So at the very beginning, for a lower cost investment about the infrastructure, so we should focusing on training AI literacy. Means that we want to promote this to many peoples. We want our AI's infrastructure that can support many users. So in this case means that we are not going to a specific infrastructure just because of the certain interest by a group of people that want to go beyond our limits. All I'm saying here is the cost that we the cost and the return that we are actually want to get the balance. So I will see what you point out here is very relevant. So what type of infrastructure should we place? I would like to suggest, if I may, is low cost. Low cost means that at least you have quite a good GPU, not the low cost 3,000, 2,000 computer. I mean, low cost means still we can have 8,000 to 12,000 or even 15 to 20,000 machine that can become our simple case for our open source training module. Means we can use that machine for a low what I call low parameters. It's 8 billions of parameters. So it's to demonstrate the logic behind it. So this is one aspect. Another aspect is the development of GPU. And people give you the idea, if I still have time. So the GPU is like a truck that is navigating around the city. So GPU is expensive. I'm talking about the high-end GPU. So it's like a truck. You are actually position that truck to navigate around your city. It means that is not really useful for our case in university or even in industry. We don't want to spend a big money because we have the GPU look like a truck, the lorry like that is, you can have a heavy loads, but you are navigating around the city. So what we prefer here is we have lightweight processor. I hope that the lightweight processor is a neural processing unit, NPU, that will be our next steps for our our consideration. That can be like a Lego concept. We can stack this NPU so that we can modify our model into a lightweight model that is like a Grab's driver that can navigate freely across our city, especially in the university setting. So what I'm trying to highlight here is the balance. How we start with. I would just suggest let us prioritize the training first because we have the expertise, and then we wait for a while, see the lightweight processor that will be a very interesting module for us to navigate around the city. Means what I'm saying here, you can implement this into a different scenario and it's configurable as compared to the heavyweight GPU like a truck navigating in your city. Okay, that's my answer to you, Sei-Ping.
Okay, so it's 12 o'clock now. It's up actually, but maybe we can still accept another question if there's any question from the floor. Eh? Final question, please, anyone?
Hi, Dr. Teh. Question
hi,
from me.
Dr. Mahalo. Yeah, hi. Thank you for organizing this. I know.
Okay, no problem, Dr. Teh. Okay.
Okay.
Last question is related to social science people. Since
that's
I
great.
saw that you present, it's a bit technical for us.
Yeah.
So which level that we need to know on this
Okay.
particular artificial intelligence matters? Thank
Sure.
you, Dr. Teh.
Yeah, thank you for your question. Yeah, so I agree that the presentation that I'm highlighted here is still mathematical oriented, but this is the nature of what this AI is all about. So as I mentioned, for me to position the AI, I try to position us in as a developers position. Means that we want to create our AI assistant. We means as a expertise in the fields, your fields, you not only to just use, but we want to have certain control and manipulation of what that might be related to your research or maybe to your knowledge advancement. So I position this as a very first place for my position today, presentation today. So again, I strongly agree with another perspective. So that will be really not relevant to against to many social science or social. No, I'm not putting this in a social. I'm not talking about is if you are not ready, want it to be in a developer context. So there will be another perspective that you can look at here is to actively involve in the or change your data analytic approach. I'm saying here is if you are the one who has the idea want to do some kind of data analysis about your social science data, I encourage you work with people in the IT or maybe engineering who will be part of your research team member who can translate your idea into data analytical process. They will give you another dimension about your human's approaches. Like for example, the human data that you are actually observe, counseling, people talking about their problem, and I don't know, maybe this is my field, it's by touch, people is about by feel. It's not that you can turn it into a mechanical process that the machine can replace us as human beings. I strongly disagree that can be replaced by machine, not at all. So this is the point. What I'm trying to say here is for a certain part, let's say you want to do video analytics, for example, beside the core counseling process that you are based on human and human communication. So there will be some video analytics that can assist you for your qualitative research. Qualitative, not quantitative. Quantitative is survey, and you can have your qualitative observation through this vision automation, language and visions summary. I want I want the the system assists me to do this at least some fundamental analysis about the video. Okay, and then from this analysis as a human, then you can go to the second level, means that intuitive understanding. So you know that the humans' feelings, which cannot be solved by this system yet. Then the human part will become later. So I encourage you to do this. Is why? Because I prefer you to have a certain digital information to be keep as your own database. Then you can reuse. If not, then this is not in the digital form, so it's difficult for you to reuse from this perspective. Yeah.
Okay, so with that, I think we end our webinar session today. Okay, thanks
Yeah.
for
Thank you.
thanks to CAM Unimas for organizing this webinar. Okay, and then thanks to the speaker also, Associate Prof. Dr. Teh, okay, for his sharing on this topic. Okay, the mechanics of AI, building technical literacy in academia. Okay, and thanks to all the participants who attended the course today. Okay, I'm not sure if CAM still want to open the QR for the staff to
Yes,
scan the
Dr. Ngo.
attendance.
Yes,
Okay.
Samizi, please show the QR attendance. Thank you, Dr. Ngo,
Okay,
the-
thank you, Dr.
yeah,
Mazlin.
for the session. Thank you, Dr. Teh.